Okay, let's look at the simultaneous linear equations and another way to solve them. We're going to have a look at how you use what's known as the elimination method. Okay, so I have got two equations. Here's my first one. Negative 2x minus 3y equals negative 9. And I've, of course, labelled that as my first equation. I've got 2x plus y equals 7. That's my second equation. Now, in order to do this elimination method, I'm going to try to get rid of one of those two unknowns that I have. Okay, because we've got two unknowns, it's very hard to figure out what's going on. So we want to get rid of one of them so that we can get an actual numerical value for one of them and then work out the other. Okay, so what I'm actually going to do is I'm going to add these two equations together. Now, this is a little unusual, so let me take you through a really easy example so that you can see what it is that I'm actually doing. Okay, let's say I've got two very simple basic questions. Two equations that are really easy. I've got 4 plus 2 equals 6 and 9 minus 2 equals 7. Well, I can actually add those two equations together to show that they can be added together. So if I write this down, I write down my first equation, my 4 plus 2 in brackets, and I want to add it to this one, 9 minus 2. I can then, because this is a plus 1 really, 1 outside of here, plus 1, I can just get rid of the brackets with no real problems. Okay, so it would just be 4 plus 2. I could do that in the brackets. And I have got my 9 minus 2, and it will equal that same as what's on this other side on the right hand side. So if I basically what I've done, let me just kind of circle it for you, is I've added, well, I didn't circle the whole thing, I've added this plus this, and it equaled this bit plus this bit. Okay, so you can see how it works in a basic sort of example, so we can apply that to a trickier one, because if you can do the easy ones, you can do the trickier ones by following the same process. Okay, so let's get back over here. So what am I going to do? I'm going to take this left hand side, and looking at this and this equation here, I don't have the same numbered y here and here. I do here. I have the same number, the coefficient, basically. So if I've got a negative 2 and a 2, if I add those two together, the x's will just disappear, and that's exactly what I want. So I'm going to write that down. Okay, so I'm going to write down my value of negative 2x minus 3y right here. I'm going to add it to 2x plus y. It's important that you put these in brackets. You'll see when we get to if we want to take them away. It's actually pretty important. I then also add my right hand sides. Negative 9 over here plus 7 plus 7. Okay, so I can then multiply out this second bracket and this bracket. There's a plus 1 out the front of both of them. That is understood to be there, but it's kind of hidden. And I'm going to end up with this. I'm going to end up with negative 2x minus 3y, that's the left-hand side of my first equation, plus 2x plus y, which was the left-hand side of my right equation, is now equal to just negative 2. Now, you can see that I do have negative 2 and I have a positive 2. And they will cancel out. I have got a negative 3y and I'm adding a y, so that is going to leave me with just the negative 2y is equal to 2. So that tells me that my y is equal to 1. I now have a numerical value for my y, for my unknown. So let's take it to do the other value, the x value. So I'm going to then substitute my value of y is equal to 1 into my second equation. So 2x plus 1, because I know that y is equal to 1. This was a y, so I'm going to just put in my value of 1 instead. And I know that that is equal to 7. I can then take 1 from both sides, and I'll get 2x is equal to 6. And I can divide both sides by 2, and I will get x is equal to 3. So the solution for my simultaneous equations, or that point where those two linear functions will cross each other, is at the coordinate of 3, 1. So with these simultaneous equations, you always do a check to make sure that everything is right. So what I'm going to do is I'm going to substitute back into number 1. That's what I'm going to do. So I'm going to do my left-hand side. So my first equation was negative 2x minus 3y equals negative 9. So I'm going to put my values of x and y, these values here, x is 3, y is 1, and I'm going to plug them into this left-hand side of the equation. As you can see, 3 and 1, x is 3, y is 1. These will then multiply out. I will get negative 6 minus 3, which is equal to 9 minus 9. And when I have a look at my right-hand side of that equation, my right-hand side was actually minus 9. Okay, so I can then just say that the left-hand side is equal to the right-hand side, so the solution is correct. Okay, you always have to have that check. How about we run through another one real quickly, because it's important to know what happens if we actually take away those initial functions, those initial algebraic equations. Okay, so here's my algebraic equations. Here's the two of them. I've got x minus 5y is equal to negative 17, and my 2x plus 3y is equal to 5. Now, I don't have the same coefficient on each of my two different linear functions here, my two different algebraic equations. So what I'm going to do is actually help myself by taking my first equation, which is just x, and I'm going to multiply each term by the same number so that I can get my x being equal to 2x. So I write that like this. I'm going to say that for my first function, for my first equation, I'm going to multiply it by 2, and I will get 2x minus 10y is equal to negative 34. And you'll note that I've called this equation the third equation. So I'm not going to really use my number 1 for the next part. I'm going to use 2 and I'm going to use 3. Because with elimination, I want to try to get rid of one of these unknowns. So here I have a 2x and here I have a 2x. So I can't add them because I'd get 4x. That's no good. So I have to actually subtract them. So I'm going to subtract 3 from 2. I'm going to subtract my new line, the one that I got by multiplying my first equation by 2 and my second equation. And once again, just like before, I'm going to put the left-hand side, starting with 3. I'm going to put this in a bracket, and then I'm going to put a minus sign, and I'm going to put this side in a bracket. That'll be the whole left-hand side. The other side will be my answers that I had from before. My right-hand side, I got my right-hand side and left-hand sides mixed up. So my left-hand side, this is from the third equation, minus the left-hand side from the second equation, will be equal to the right-hand side from the third equation, minus the right-hand side from the second equation. Okay, so that might be easier if I go and do a little quick bit of circling. So this one goes to here, this one goes to here, and this one from here goes to here, and this one here goes to over here. Okay, so we're basically making a big monster mash of these two equations to get a single equation that we can work with. All right, so let's talk about what happens when you are taking away these things. There is a secret 1 hidden out the front of here. There's a plus 1 out the front here, and there's a minus 1 out the front of that one. Okay, so we don't normally write that in, but it does have an effect here. If I multiply out this, I'll get positive 1 times 2x, that'll just be 2x. Negative 10y multiplied by 1, positive 1 will just be minus 10y. But negative 1 multiplied by 2x will be actually minus 2x, and negative 1 times positive 3y will be minus 3y. That is a super important step that you can't miss here, right? If you've got a minus, if you're minusing these two left-hand sides, you must end up with negatives inside of here if you had negatives inside of here to start with. If you had a minus there, well, the -1 times that minus there would turn that into a positive. All right, so it's really important to remember that there's a -1 at the front of that. All right, and we've got a -34 minus 5, which I'm hoping that you can see enough of to know that it's there. That'll be -39. Okay, so the long shot of all of this, and the reason why we did this, is now we've got 2x minus 2x. Minus, that just will go away. That just cancels itself out. So really we've got -10y minus 3y is equal to 39, -39. Okay, so that will be -13y is equal to minus 39. I can divide both sides by -13, and I get a numerical value for my unknown value of y. It will be 3. So I have that information. I'm going to substitute my y is equal to 3 back into one of my original equations, back into 2. So I will rewrite that one so that you can see it was 2x plus 3y equals 5, but now I know that that y is actually a 3 right here. That will then become 2x plus 9 equals 5. I can then take 9 from both sides. 2x will be equal to -4. I can then divide both sides by 2, and I'll get x is equal to -2, and the solution for my simultaneous equations here will be x is equal to -2, y is equal to 3. Now once again, we always have to do our check. So I'm going to substitute these values back into my first equation. I haven't used the first equation from the very beginning, so let's sub it back into there to see if it's all okay. So my left hand side will be equal to x minus 5y. So it'll just be -2 minus 5 times 3. So it'll be -2 minus 15. So it will be -17, and my right hand side is 17. So therefore I can say that my left hand side is equal to my right hand side, and the solution is correct. Now these are not short, quickly answered questions. There is a lot of working out. You need to show every step so that you don't get lost. It's super important. Be very careful of if you're taking away these lines, these equations from each other, you end up having to multiply out a bracket using the distributive law with a -1, which will change signs. Be very careful of that. Okay.